Welcome back to Think Thrice Problem Solving. Today we're going to look at this complex variable in exponential form and talk about how we can represent it as cosine of x plus I sine of x. And to do that, we're going to use Taylor series approximations. So if you'd like to do this on your own, go ahead and pause the video and try it out. Otherwise, we're going to go ahead and jump into our solution. So let's, to start out, let's talk about what a Taylor series approximation is. So if I have some function and I want to approximate that, I'm going to approximate it at 0 because we're going to go to infinity. So this is technically a Maclaurin series. But we take a sum of terms. So we start at n equals 0 and we go to infinity. And what we do is we take the nth derivative of a function evaluated at a point. And as I said, we're evaluating at 0. We divide that by n factorial. And we multiply that by x to the n. Okay? And when we do this, if you want, I can do a future video that shows why this is true. But essentially what we're doing is we're matching the derivative of our function so that the derivative and the second derivative and the third derivative and the fourth derivative are all equal to our function at that given value 0. So let's look at a few of these different functions. So let's first look at cosine of x. So if cosine of x, if I take the derivative of cosine of x, I'm going to get negative sine of x. If I go to the next, so if I go d squared of cosine of x, I'm going to get negative cosine of x. And then if I take the third derivative, so I'm going to start just abbreviating here, the third derivative is going to be sine of x. And then I'm going to be in a loop. The fourth derivative is going to be cosine, then sine, cosine, then I'll be going through this routine again. So when I write out this expression here, so I can say that f of x is going to be equal to the first term. So f, my 0th derivative is just my function. So cosine of 0 is going to be 1 divided by n factorial, which is 0 factorial, times x to the 0, plus negative sine. So I'm going to take that negative sine and evaluate it at 0. So that's going to be 0 times a bunch of other stuff. And then for my third term, n equals 3, I'm going to look at this next derivative. And I'm taking the second derivative now. So the second derivative evaluated at 0 is negative 1. I'm going to multiply that by 2 factorial, and that's going to be times x squared. And if I look at the next term, I'm going to get plus 1, plus 0 because it's sine. And then I'll go back to the first function, and I'll end up getting plus 1 over 4 factorial times x to the 4th. And then it'll be plus negative 1 over 6 factorial times x to the 6th, and so on. And we can see that we've developed a pattern now. So the Taylor series approximation of my function is just going to be 1 minus 1/2 x squared plus 1 over 4 factorial x to the 4th minus 1 over 6 factorial x to the 6th, and so on. Okay, so we're going to kind of mark this. This is my cosine of x. So this is cosine of x. Okay, so now we're going to look at sine of x. So if I look at sine of x, if I look at the first derivative of sine of x, I get cosine of x. The second derivative is negative sine of x. The third derivative is negative cosine of x. And then my fourth derivative will be back to the start. I'll just have sine of x again, and I'll start rotating through those. So similar to above, if I take the Taylor series approximation of this, then I'm going to get sine of x is equal to 1 over 0 factorial, so sine of x evaluated at 0, which is 0. So this first term is just going to be 0. Then I'm going to get plus cosine of x evaluated at 0, which is 1 over 1 factorial times x to the 1. Then I'm going to get my next term, so I get plus 0 again, sorry. Sine of x is at 0 is 0. And you get plus negative cosine of x evaluated at 0, which is negative 1 divided by 3 factorial times x cubed. And if I keep doing this, I can see that I've started to develop a pattern. So I'm going to get plus 0 plus 1 over 5 factorial x to the 5th plus negative 1 over 7 factorial x to the 7th. So I can rewrite this now kind of the same way as above, that sine of x is equal to 1 times x, so just x, minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the 5th minus 1 over 7 factorial x to the 7th. Okay, so I have approximations for sine and cosine. So now what we're going to do is we're going to do e to the x. So we're going to take a little bit of a break from what we did above, and now we're going to look at the function e to the x. So what I notice is the derivative of e to the x is just e to the x. So I'm always going to have just e to the x. So if I wanted to do this Taylor series approximation, I see that e to the x is going to be and e to 0 is always going to be 1. So e to the 0 is always equal 1. So that f to the n of 0 is always going to equal 1. So essentially what I'm going to have is 1 over 0 factorial times x to the 0 plus 1 over 1 factorial times x to the 1 plus 1 over 2 factorial times x squared plus 1 over 3 factorial times x cubed, and so on. And that'll just continue as we move to the right. Okay, so what we're going to do here, so remember what we were doing in our original equation. We were looking at e to the ix. So what happens, instead of taking e to the x, what if I take e to the ix? So if I look at e to the ix, what I'm going to get is this is equal to 1 plus 1 over 1 factorial times ix, so ix, plus 1 over 2 factorial times I squared x, so that's going to be x squared times negative 1, because I squared is negative 1. And I'm going to get plus 1 over 3 factorial times x cubed, which is going to be I to the 3rd, which is going to be negative I times x cubed. Be consistent here, sorry. Make that green. Okay, and then I'm going to get plus 1 over 4 factorial. And now my sign here is going to be I to the 4th, so that's going to be I squared is negative 1, negative 1 squared is positive 1. So I'm just going to get x to the 4th. And this will continue on. And what I notice here is if I split this up and I look at e to the ix, then it's going to equal something interesting. So if I pull out everything that's not multiplied by I, then I'm going to get 1 plus negative 1 over 2 factorial times x squared plus 1 over 4 factorial times x to the 4th, and so on. And then I'm going to multiply, or I add this to everything that does have an I. So everything that does have an I is going to be x plus negative 1 over 3 factorial x cubed plus, and then it'll end up being positive 1 over 5 factorial x to the 5th, and so on. And what I notice here is that I have exactly my cosine of x approximation right here. So this is my Taylor series approximation for cosine of x. And right here, I look at my sine of x approximation, and I have exactly that Taylor series approximation right there. So this is where we kept that magical expression. And now we're going to say that e to the ix now, what we've shown is that that's equal to cosine of x plus I times sine of x. So that's why we can go ahead and use that substitution and say that e to the ix is equal to cosine of x plus I sine of x. So if you enjoyed this video, please like and subscribe. If you have your own problem that you'd like me to solve, please submit that via email. And as you're working out problems on your own, think once, think twice, and if you get stuck, think thrice.